All right, the last unit of Unit 2, 2.9, two parts, right? This is part 1. So in the same way we did properties of equality to apply to algebraic proofs, right? We also need to do segment proofs, right? Line segment, lines, right? And some of the properties of equality apply, which means you already know most of it. Great. But these properties can only be used on equations. Right? So we also need to learn 3 new properties that are specific to congruence. So what's the difference between equality and congruence? Very little. All right? This is equality. This is congruence. That's it. That's the difference. All right? So I'm going to write that under there. Equality. Congruence. It's just a matter of word use, right? But we can use the properties of congruence to turn them into equations, which then means we can use all the rest of the properties. All right, so the properties of congruence. Properties of congruence. We have the reflexive property of congruence, right, which is very similar to the reflexive property of equality. The difference is for any segment AB, right, segment AB is going to be congruent. So it's going to have a congruent symbol to segment AB, right? It's congruent. It's the same. It's basically 5 equals 5, except we're using segments. It's A equals A, except we're using segments, right? So it has to be equal and identical for it to be reflexive. Equal and identical. All right, symmetric property, right? So if segment AB is congruent to segment CD, then segment CD is congruent to segment AB, right? Switched. So the original and the converse is true, right? In order to be symmetric, they have to be equal, but not identical, right? And then we have transitive property, our law of syllogism again, or PQQR. So if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is also congruent to segment EF, right? So this is where we recognize our PQQR. PQQR. This is why transitive property and the law of syllogism are the same thing, right? Because if you have PQQR, then you can go straight from P to R, right? That's all transitive property is. So these are specific because they're called properties of congruence. And that means they're going to have this symbol. So let's look specifically at the definition of congruence. Segments are congruent if and only if, there's our code, sorry, if and only if, so it's a biconditional statement, which means it has to be true in both directions, right? Segments are congruent if and only if they have the same measure. So if segments are congruent, I don't know if I want to write it that way. Hang on. Let's use the letters. Let's be specific about our segments. If segment AB is congruent to segment CD, then they are equal. They have the same measure. Then segment AB is equal to segment CD. Remember how I said we could use the laws, the definitions, to move it from congruent to equal so that we could then apply the properties of equality? You use the definition of congruence to do that. Right? But remember, biconditional means it's true in both directions. So, if segment AB is equal to segment CD, then segment AB is congruent to CD. It has to be true in both directions. This is true in both directions, so it's biconditional. And it's literally the definition of congruence. If it's congruent, then it's equal. If it's equal, then it's congruent. They're the same thing, different words, right? The midpoint of a segment divides the segment into two congruent parts, equal, right? So, the definition of midpoint, if M is the midpoint between A and B, then A to M, the segment AM, is equal or congruent to segment MB. This piece is equal to this piece. Right? You could put equal or congruent. They're the same thing, people. Right? If this is the middle, the midpoint, then this piece is equal to this piece. Make sense? All right? Now, we bring in our postulates. Don't forget our postulates we learned about. All right? Segment addition postulate. Right? Remember, if A, B, and C are collinear on the same line, and B is between A and C, which it is, then this piece, right, segment AB, plus this piece, segment AC, nope, BC. Equals the whole thing, right? A to C equals segment AC. The whole thing. This piece plus this piece equals the whole piece. That's our segment addition postulate. Right? So if this is 7 and this is 3, then the whole thing together has to be 10. Segment addition postulate. All right, now let's practice. So we're going to look at different claims, if-thens, different claims, different statements, right? And we're going to determine which law does it prove. Which law does it prove? Which property of equality or property of congruence or postulate are they using to prove that statement? All right, if P equals Q, then PQ, I read that wrong. I apologize. Let me start again. If PQ equals PQ, then segment PQ is congruent to segment PQ. We went from equal to congruent. That is literally the definition of congruence. It is literally the definition of congruence. If K is between J and L, then J to K plus J to L to K is equal to J to L, right? Segment plus segment equals total. That's segment addition postulate. Segments, addition, postulates. All right? Segment EF is congruent to segment EF. Equal and identical, right? That's reflexive property. Reflexive property of congruence. Why am I saying of congruence? I'm specifying of congruence because the congruent symbol is there. If it was an equal symbol, then I could say reflexive property of equality. But because there's a congruent symbol there, it's the reflexive property of congruence. If Rx is equal to TU, you see how there's an equal sign instead of a congruence sign? That means we can use the properties of equality. If Rx is equal to TU, then Rx plus xy equals tu plus xy. So how did we get from here to here? We added xy to both sides. That's addition property. That's addition property. If AB equals DE, then DE equals AB. Again, we have an equal sign, so we can use the properties of equality. And it looks the same, it's just switched. Equal but not identical is symmetrical. All right, 6. If y is the midpoint of x segment xz, then xy equals yz. If y is the midpoint, right, then this is just midpoint, right? You can literally just put the definition of midpoint. Definition of midpoint. If segment FG is congruent, we're using congruent, so we have to use properties of congruence. If segment FG is congruent to segment HI, and HI is congruent to JK, then FG is congruent to JK. That's a lot of information, but I want you to remember PQQR. If P, Q, Q, right? They're the same. R. If the center is the same, they cancel each other out and you create a new statement. You go straight from P to R. This is the law of syllogism again. But as it applies to algebra or segment proofs, it's just called the transitive property. And because we have the congruent symbol, we're going to say it's the transitive property of congruence, right? Transitive property of congruence. All right, so pause it, try it, see what you get. 8. If AB plus CD equals EF plus CD, then AB equals EF. P, nope, that's not, yeah, it is because they're backwards. PQQR. The property still applies. They just wrote them backwards. Right? If you were to flip these, commutative property, if it's addition, you can switch them around without changing anything. Then you would see transitive property here. And it's an equal sign, so it's transitive property of equality. What gave it away for me? When I was reading it, I noticed very quickly that this repeated. And then in the end, it disappeared. That tells me it's transitive property. If PQ plus RS equals TV, and RS equals WX, then PQ plus WX equals TV. Now I want you to think about that for a second. What did they do to get from here to here? Well, they figured out that if RX is equal to WX, then they could substitute RX with WX. They could replace it. Substitution property. And because substitution, it was an equal sign, we can use the properties of equality. So it's substitution property. If LP equals PN, and LP and N are collinear, this means we can use properties of equality. This means they're all on the same line. Then P is the midpoint of LN. It's telling you that there is a line segment. We have LPN, and it's telling you that P is the midpoint, which means this is equal to this. Like, it's basically the definition of midpoint, right? It's the definition of midpoint. Definition of midpoint. It's almost like somebody said, explain to me how midpoint works. And they said, okay, this is how you explain that. This is the definition of midpoint. All right, 11. If segment UV is congruent to segment UV, then UV is equal to UV. Congruent to equal. That's the definition of congruence. That's literally the definition of congruence. If CD plus DE equals CE, then CD equals CE minus DE. So how did we get from here to here? We know it's an equal sign, so we know we can use the properties of equality. So let's think about our properties of equality. What did they do to this equation to get to this equation? Well, this moved to the other side of the equal sign, which means they had to subtract it, right, from both sides. They had to subtract it from both sides. Both sides of the equation, both sides of the equal sign. If they subtracted it in order to cancel it, which is what they did, then that's subtraction property. And I don't even have to write subtraction property of equality because there is not a subtraction property of congruence, right? Only property of equality. And we can only use it because we ended with an equal sign. Equal equals. So we can use the properties of equality. If 2xy is equal to xz, again, we have an equal sign, so we can use properties of equality, then xy is equal to 1/2 xz. So how did we go from here to here? We divided both sides by 2. Right? Because remember, in front of a variable, a naked variable, there's an invisible 1. This is how they get the 1/2. In front of any naked variable is an invisible 1. So if we divided both sides of the equation to get here, then that's division property. And 14. If RS equals ST and ST equals TUV, then RS equals TUV. Hopefully you caught it just as I did, right? These repeated. That's transitive property. And it has an equal sign, so it's transitive property of equality. Transitive property of equality. When you looked at the, hopefully you have the practice sheet for this. Probably not. But at the bottom of the practice sheet is your reasons bank. But it's okay because it's also in the reference sheet we just did at the top of this, right? It's also up here. So it's not like I didn't give it to you, right? Properties of equality, properties of congruence, and your 2 definitions you're going to need, plus the postulate you would need. So if you wrote it down, then you had your own reference sheet and you didn't need the reasons bank.